Hello, fellow humans, and welcome back to Beyond Words, conversations on language, music, and mind. I'm your host, Garrett Oyama. In this episode, I'm joined by Dr. Idan Blank, a cognitive neuroscientist and professor at UCLA, whose work explores the deep structure of language in the brain and what it means to truly know a language. We talk about his unique path from theater director to language scientist and dive into why language and thought aren't the same thing, despite what your inner monologue might suggest. We explore how our brains process meaning, what large language models like ChatGPT are teaching us about linguistic intelligence, and why most standardized language assessments may be measuring the wrong things. Dr. Blank walks us through what Broca's area actually does and why we need to stop treating it like a one-size-fits-all center for language. From modularity in the brain to statistical learning in kids, from distributional semantics to pragmatic sensitivity in AI, this conversation bridges neuroscience, linguistics, and speech therapy in exciting and new ways. So what lies beyond the words we speak? Tune in and find out. So without further ado, Dr. Blank, welcome to Beyond Words.
Thank you. Thank you so much for inviting me. I'm really excited to be here. I think this is going to be really fun and exciting.
Yeah, I'm super excited as well. I always ask the guests just a little bit about their superhero origin story. And I'm just wondering what got you interested in this pretty broad field of language, neuroscience, and computation. What got you interested in this?
It's a great question. So as you mentioned, when I started my academic career in Tel Aviv as a student, one of the things I studied was theater art. I still think of myself as mainly a theater person. And I tell people that I want to be a director when I grow up. And my fascination with language, at least academically, really started there. So I was very interested in directing plays. And a lot of what you do when you direct plays is not understanding what the characters are saying literally, but understanding what they are saying in between the lines and how we affect each other and how we act on each other via words, what people call how we do things with words. And so, I wrote a lot of term papers about language in the theater department and tried to practice as a director a lot of sort of trying to think about language and how it's used. And I was really fascinated by plays that sort of try to explore the format of language as an artistic medium. I really wasn't studying language and psychology at all. I was doing my master's in psychology, and my goal there was to, study with the best scientist I could, regardless of topic. And I met Professor Galit Yuval, who is still a dear colleague and friend, and she studied face perception. So I thought, okay, that's what I'll do. I originally thought it was very boring. Then I fell in love with it. And I still love visual processing. And I actually went to my PhD at MIT to study face perception. And that's where I really switched to cognitive science of language, because I always had this side passion of language that was mostly in theater. And at MIT, my co-mentor, Eb Fedorenko, convinced me that you can also study language with scientific methods. Originally, I was a little skeptic. I told her, we barely understand how the brain does vision. Language is so much more complicated. How can we ever hope to study that? And she told me, well, why don't you try that for 5 years in grad school? And if you still think we can't make progress, then switch to another field. And so I said, fine, let's do that. And then I stayed.
So cool.
Yeah. So that's how I got here.
Yeah. Feel a kindred spirit in that, I often tell people I'm just a musician, and that's how I got interested in language as well, just through, I guess, this sort of feeling that you get playing with other musicians. There's this deep communication there, but then, being really interested in the differences between, semantic communication and its more symbolic representation and things like that versus this kind of different sort of musical communication. But yeah, I love to hear people's different paths to get to where they are. And, speaking of language, a lot of people, speech therapists included, they often conflate language and thought, and I think it's because it's just used as the most efficient way that we judge people's intelligence. And, we've just sort of used it for so long that we've forgotten that it's actually a heuristic. And I was wondering if you could talk a little bit about how your research has challenged this basic assumption that language and thought are the same thing.
Yeah. So I think there are two ways in which this question about the relationship between language and thought goes. One is whether we think in language, right? Whether language is really the vehicle of thought. So when you create thoughts and manipulate them, do you sort of manipulate the same types of representations as you do when you produce and comprehend sentences? Or do you use some different type of mental code and languages for translating it to communicate it to other people? So that's sort of whether language is used for thought. The other direction is to what extent are general cognitive abilities used in language. And so, as exactly as you said, throughout history until large language models, the only systems we had that used language proficiently were humans, and we are also very good at thinking. And so we just assume that these two things go together, right? Some of my colleagues call this the fallacy of good at language, good at thinking, right? That if someone is very good at language, they're very good at thinking. We know that there are very strong dissociations between the two. So there are people who have some cognitive deficits that are pretty severe, but their language abilities are either largely unimpaired or impaired to a much lesser extent. And conversely, we have people with very severe language disorders, but their thinking is, very much intact. And so a lot of the research I did was about how thought contributes to language. Now, of course, to use language in the real world, like you and I are doing right now, it's not enough to know syntax and the meanings of words, right? We have to have common sense. We need to be able to think about each other's thoughts, to communicate well and read between the lines. We need the ability to create world models or situation models, right? Understand narratives at large. So of course, all of these things are important for communication, but there have been many claims that general cognitive abilities contribute to language on a finer scale. So for example, that abilities like IQ or components that contribute to your IQ and your intelligence, such as your ability to hold things in working memory or your ability to inhibit things that are currently for the current context aren't important, or your ability to resolve conflicts between conflicting types of information, that all of these things that are very important for intelligence also contribute to language. For example, that some of that literature that supported this is literature from older adults. There have been some claims that, their general working memory and cognitive abilities decline, and there are some claims that also their language abilities decline, although I think some of those claims are problematic. But anyway, there's a very large literature of fMRI showing that if you look at brain regions that sort of support fluid intelligence, they also light up especially when language gets hard. And so a lot of my research started by asking, okay, so what exactly do these broad intelligent components do for language? Like, we know that these regions light up, but what exactly do they do? And it turned out throughout my graduate school that they really don't do much. So I was really, really surprised by that. And I don't want to say that they do nothing. I think they do much, much less than we thought. It's still an open question. What I have discovered, and what I think, is that many of the past studies, there are like 20 years of studies that show that these general intelligence regions light up when you do language, is because when you put people in the scanner, you give them language tasks that are very artificial. Right? So you show them two pictures and you give them a sentence and you ask them which of these pictures is described by the sentence, or things like that. And that turns language into problem solving. And so when you turn language into an IQ test, of course, you're going to need the parts of your brain that support IQ, right? When you take all of that out, so what I've started doing is putting people in the scanner and having them just listen to stories. I'm not the only person who does this. I didn't invent this. But when you do this way more naturalistically, those IQ regions do very little, if at all. Now, I don't mean to say
that's crazy.
Yeah, I know. And we didn't believe it. So we did one study after another. At this point, we have at least 10 different studies that show the same pattern, no matter how we looked at it. Now, I don't want to say that keeping things in working memory or inhibiting things that are irrelevant or monitoring conflicts are not important for language, right? For example, if I say the word bank, you really need to inhibit one meaning, right? Maybe the meaning that means a financial institution, and access the meaning that's important. For example, if I'm talking about the Bank of River. But what seems to be the case is that the language system has its own pool of resources that do those things. And those are separate from general intelligence. I think that this is also really important for language evaluations, including those that are done by speech language pathologies, right? Because a lot of these are tasks. And are artificial, and they might accidentally tap people's fluid intelligence, right? All of these other cognitive abilities. And so when someone doesn't do well on these tasks, it might not represent a failure of language, right? It might represent other types of cognitive impairment.
Oh, yeah, in so many ways. Yeah, when one thing that I'd written here to talk about was that when you mentioned this, that like when you put people in scanners and you give them these artificial tests that they turn into problem solving tasks, I thought back to all the language evaluations I give, and I can't think of a single one that doesn't do something like this, where it's like, touch the star that's above the this thing and that thing, and it's like, wow, we might be really testing kind of the wrong thing. It really casts doubt on a lot of what's going on in these evaluations. And it's so funny because you'll have it also, there's a point of, sometimes it's just about knowing the definition of a word, for an evaluation. And maybe the kid that you're testing, they can't tell you the exact definition, but then 10 seconds later, they're using that same word in like natural context. And it's just so interesting. But something that we definitely have to think about as therapists.
Yeah, I completely agree. And the example of a definition of a word is very interesting, because think about extending this to a more complicated level, like the rules of syntax of how we put words together, right? Most English users cannot tell you what those rules are, right? And yet they can use them perfectly well all the time. Like when undergrads come to my linguistics class, I teach them all these regularities in how we put words together that we implicitly know. And they look at me, like, we don't know this. And I tell them, no, you do. You do this implicitly because you use language, in a way that aligns with the conventions of how the rest of us use language. And so you all know this implicitly. Now, of course, I think very few people would imagine asking someone in an SLP context as a task to tell you some syntactic rules of English, right? We don't expect anyone to actually be able to explain these rules, even though we expect them to be able to use them, right? If their language abilities are not impaired. So why would we do this with words, right? Why would we ask someone to define a word? By extension, right? It might also make very little sense. What's important is whether they can use it properly.
Yeah, absolutely. This gets into, man, so many important points, I think, for therapists, and some that we sort of know, I think, implicitly, like, just because you say something doesn't mean that you understand it necessarily. But on the flip side, just because you understand and even can reason about something linguistically, it doesn't really mean that you experientially know what that means. And I think this is getting to a point a little bit about LLMs that, if LLMs, they can talk about, they could speak about things pretty well. And, it kind of seems undeniable at this point that they are really good at formal linguistic competence. But this doesn't mean that they're not really grounding these symbols in anything. So yeah, I maybe wanted to know what are your thoughts on the theoretical implications of this?
Yeah, I mean, I keep changing my mind a lot as these models develop, right? I think what has been very, very interesting and was pointed out to me by Josh Tenenbaum at MIT is that, today we have large language models that also process images, right? So you can say, even though early language models only worked on text and they could use the word dog and even describe in language what a dog looks like, but they haven't experienced visually what a dog looks like. Now they do get images, right? Some of them get sounds. So they might have a more embodied, right, grounded understanding, maybe. We didn't used to have them. And when we only had models that worked on text, their linguistic abilities developed much, much faster than their conceptual abilities, right? So they could produce sentences that were well-formed in terms of structure and kind of made sense for the most part. But if you really put them to the stress test, it was clear that they weren't thinking, right? At least not in the way that we say humans are thinking. And so I think that really demonstrated this dissociation. And it was very hard for these models to develop thinking. I think it required a combination of stuff. It's unclear exactly the roles that different components played. So one thing is just making the models bigger. To my great surprise, it seems that just having larger language models allowed them to behave in ways that some of us would call intelligent. But the other part is also training them on different objectives, right? So each of these models is trained to meet some objective. The original objective was just training them to predict the next word. It turns out, and that was surprising as well, that just from learning to predict the next word, you learn so much about what language is and how to use it. But maybe you don't learn a lot about how to think. In addition, train them on other things. For example, responding in a way that people liked right? That people said, yes, this is a good response to what I asked, or no, that's a bad response to what I asked. They seem to have gained some other abilities better or faster, right? So, for example, being cooperative, right? Maybe understanding intentions, maybe, right? Or at least behaving in a way that some of us would interpret as understanding intentions. I don't really think that they do that very well, but that the models. So yeah, I think there is a very big dissociation. What was also interesting is how much you can learn about the world just from language, just from internet texts.
Yeah.
Because these models know a lot, right? Like you ask, sometimes they confabulate, sometimes they make up things, but the more advanced they get and the more you train them, they mostly seem to sort of understand what's going on, right? Even about things that are not about language at all. Now, interestingly, we have some cases like that in humans. So for example, if you take people who are congenitally blind and they've never seen anything in their lives, and you give them words for color, and you just ask them, how similar are these? So how similar is yellow to orange, or yellow to red, or green to red? You get the same color wheel if you just place the color words based on similarities, same color wheel that you get from people who are sighted.
Crazy.
Right?
Wow.
Now, how did they learn this? Maybe they were explicitly instructed, right? Maybe if you need to get dressed as a blind person, someone tells you, this shirt is blue, these pants are gold, blue and gold don't go together. But another possibility is that they just notice how language is used in terms of which words are used next to each other. So for example, you would say reddish yellow, but you would never say reddish green, right? That's just not an experience we have. So if you just notice how words are used, you might implicitly learn such things, right? So this is a case where some humans learn about the world in ways that may be more similar to how large language models learn about the world.
I see. Is this what you'd call the distributional hypothesis?
Yes, exactly.
Okay, amazing.
The idea that the meaning of a word to some significant extent is influenced by how it is used. So not just something inherent to it, but how it's used with other words. And if you take a word and use it in a different way, then its meaning would change.
Yeah, so cool. Yeah, you had this paper on semantic projection, and that really, it made me think of, we also talked to Jenny Safran on the podcast not too long ago, and she talked about how as infants we're picking up on these statistical patterns in language at the the kind of the phoneme level, but this sort of suggests that there's so many other patterns in this maybe high dimensional space that we're picking up on, that somehow language itself, just from our experience with hearing a bunch of language, that this structure itself has a bunch of the sort of meanings embedded in it. Is that what?
Yeah, I agree. So the paper you mentioned, if this paper was way before large language models, or at least we started working on it when they just started arriving. If you take large language models today, as we said, right, you probe their knowledge, you just ask them questions. They know a lot of stuff about the world. I'm very interested in how you get that knowledge and what sort of are the minimum components that can give you that knowledge. And with large language models, it's very hard to know because you train them on massive amounts of text and they can model very complex relationships between words. So what we asked is, what if you just tracked which words tend to occur near each other without understanding sentence structure or syntax, without actually knowing the meanings of words, nothing, just the simplest, almost dumbest thing you can track about language. And we know that humans are very, very sensitive to which words tend to co-occur next to each other. We have a lot of behavioral evidence for that. So we took a model that is sort of the predecessor of large language models. It's called a word embedding, and it's basically it just learns which words tend to co-occur next to one another, and it only knows how to represent words. It cannot represent phrases or sentences in any principled way. And we ask, what does that model know at all about words? And we discovered that it knows many surprising things. So for example, it implicitly knows which animals are bigger or smaller. Even though, humans, I assume, mostly learn it from looking, right? You don't really need language. But even in the subtle ways that we implicitly use language, which words occur next to each other, that's there. Other people have found that a lot of stereotypes, like stereotypes about gender, are hidden in which words we put next to each other, not in the meanings of sentences we say, right? Even if we don't say some terrible sentence like, women belong in the house, even the implicit way we put words next to each other, that way hides a lot of stereotypes. We found that, you sort of these very dumb models know about which mythological creatures are more dangerous or safe, right? Like a devil versus a fairy, or yeah, which names are male versus female typically, and which are kind of unisex. So yeah, a lot of knowledge just from this dumb statistical learning of which words are used next to which other words.
That's so cool. Yeah. It's amazing to me that it feels like those things are so, they seem to be so environmentally context dependent. Like I think you gave the example of like dolphin and alligator, and like, you see where they fall on like the danger scale, for example. And it seems like you'd need to like live and, see examples of this to know, but it's crazy to me that you can, just from how these words are clustered together, that you can, get that information. What it sort of suggests to me as a therapist, thinking about how we, thinking about language development, is that, it's really important that we have a lot of exposure, because, it seems like the meaning, if it lives in these like kind of relationships, we can't just have one example. Like we can't just learn from, like, we can't just take a dictionary and then read off that definition and know, the meaning lives in relationships, and how, even if it's not necessarily all embodied, like we can learn from how words cluster across many examples. So, it's important to have a ton of exposure. Yeah. Do you think that this could be ever used in like in an evaluation context or something like that? Do you have any thoughts on that?
It's a very good question.
Or just any other thoughts about?
Yeah, I mean, so one thing is, something as simple as rating similarities of words, right, can maybe tell you what someone knows about meaning, even if they cannot define the word, right? So some more implicit measures like that can maybe help you gauge people's language knowledge, and maybe whatever is implicit inside of it, even if explicitly, they can't define a word.
That's so interesting. Yeah, because I think as SLPs, you sort of get the sense that kids, they have a sense of a word, even if they don't know the definition, and even if they don't know exactly when, like all the places to use it, they sort of have a sense of where it fits.
Right.
And that it's like a continuous scale almost. It's not like a, it or you don't. It's like, yeah.
Exactly. And all of us, the first time you hear a word, you already start tracking it, and you already remember, at least temporarily, even if this memory trace is very weak, you remember how it was used, and you keep collecting statistics about these usage patterns. And right, the more examples you get, the more refined or rich your knowledge of how to use that word is. Kids make very strong inferences, even from one or two examples. Again, those might not be very, very accurate, but they still make very strong inferences. So we definitely leverage relatively little data to learn very quickly. In fact, even if you take all of the words that a kid hears, right, like the amount of exposure they have until the age 5 or 10 or whatever, this is orders of magnitude less than what large language models do. Right. So they learn to use language very, very well, but they need massive exposure, at least in the sort of vanilla traditional way that they're being trained. There are some groups these days that try to find ways to train them more quickly, and to train them on input of the same size that kids get, which would really allow you to have these models be more useful as models of humans, right? Not just as AI tools for technology, but allow us to ask how language develops, right? Which is also important, because then we can ask, how does language break down?
Yeah. Yeah.
Oh.
This is the data gap, right?
Yes, exactly.
Yeah.
The data gap. And so there are many interesting works in that domain. There's something called the Baby LM Challenge, LM for language model, where different teams try to compete with, making language models that are trained on very small corpora, that are taken from the type of input that kids get, and see how far you can get a model with just that input. There are other groups that try to sort of give models inductive biases, right? So biases that would help them draw inferences from very few examples, which current models can't do. I'll say one thing I'll mention is that, many people critique language models based on this data gap, right? They say, well, they need so much data. Who cares if they end up being very good at language? They don't do it like humans do. But they miss the fact that the human brain comes with a lot of inductive biases that are the product of years of evolution, which is kind of a form of learning vaguely, right?
Yeah.
And large language models need to do both. They need to do both evolution and development, right? Because they start with very few inductive biases. And so maybe it's not that surprising that they need so much data to learn, because they need the evolution part in addition.
Huh.
So
That's so cool. So what do you think? What is your thoughts on, so, you have this paper on the neural architecture of language and predictive processing. And, you looked at these sort of just with the architecture of next word prediction itself, like that these models are actually really good at, matching human scores. And I'm wondering, what are your thoughts on, given that the language network is pretty modular, do you think it's doing something similar? Is the like underlying architecture sort of built on this next word prediction, or is there something else going on?
So yeah, it's really, really interesting. I mean, I think there's so much evidence from all of cognitive science that predictive processing is a huge aspect of the mind, not just in language, right? So even though we are continuously flooded with input from the world, visual, auditory, linguistic, everything, we don't just process what's happening now, we also predict what's coming next. And there's evidence from neuroscience and from behavior and from modeling that this predictive processing is very, very important. And it seems to be a fundamental way of how the brain and mind work.
Mm-hmm.
And so by extension, yes, I think it's very, very important for language as well. And there is a lot of evidence that your language system starts to predict pretty much as soon as we can measure. Like, you don't even wait for the end of the first word or the end of the first syllable to try predicting what's coming next. Mm. So we are very good at it, and we do it all the time. So it's very nice and exciting that training a model just to predict the next word, even though, they learn it from text, they don't hear. So there are many, many differences from humans, but still training these models, A, makes them good at language, and B, allows you to open them up and look at their internal patterns of activity when they process a sentence. And that kind of predicts what the brains of humans who read the same sentence or hear the same sentence would do. So that alignment is very, very exciting. In our paper, I think it remains to be seen whether this really replicates. It seems like training models, large language models, on other goals or objectives doesn't make them align with the brain to the same extent, or at least with the language parts of the brain. So it seems like you don't want to train the brain on anything, you don't want to train the large language model on anything and would become brain-like. There are some things that work better. There are some other people who suggested that it's not unique to predictive processing. You can also train these models on odd things like translating from one language to the next. And the better the model gets at translation, the more brain-like it looks. And that's odd. We wouldn't want to say that all of our brains translate, right? Some of us are wolves. You might claim that when you train language models on these tasks, they implicitly learn to do prediction. And so the reason they become more brain-like is that you translate well, you have to do prediction anyway. Maybe, maybe not. I don't know. That remains to be seen, but that's one hypothesis. So yeah, I think predictive processing is hugely important for language. I think I underestimated how important it was until large language models, which really showed us how far you can get just with that. That being said, we know that the human mind has different networks that all work together, right? They're not like independent, but they use different formats of representations, right? They have different mental codes. They do separate things, even though they collaborate, right? You can think of this as different divisions in an office, right? They each have their specialty, but of course they all somehow work together and exchange information. And the language system is only one of them. When you take something like ChatGPT that does language, and some people want to say that it also thinks, right? It can think, it has, maybe some people claim social cognition. I'm a little skeptic. It has some forms of reasoning that seem to be quite robust, and some other things. They might all happen within, in a mixed way inside ChatGPT. That's very different from the brain. There are now people that are asking, if you open ChatGPT and you look at its or smaller systems that we actually have access to, and you look at their different artificial neurons, do you actually get a separation between those that do language and those that do other things? So does the model somehow, just by trying to solve next word prediction, learn that the best way to solve this problem is to separate into different subcomponents? And there is some initial evidence that yes, that it kind of happened. it mirrors other cases. So for example, it has been shown in vision that if you train a model to recognize both objects and faces, it would learn to separate face processing neurons in like artificial neurons from object processing neurons in the same way that we see in the human brain, even though you never tell the model to separate these, suggesting that it's the nature of the problem that if you want to save it, if you want to solve it in the best way, you should separate those two subproblems. It might be the same with language versus aspects of thought. And there are now teams that are trying to build new language models. They are mostly small and for scientific studies, not for commercial use, where you build link together several small large language models that each is trained on something else. Some are trained on math and logic and reasoning. Some are trained on social stuff. Some are trained on language per se, right? And to try to see whether that makes them better at some task, whether that makes them predict brain activity better. I think that if we want commercial systems that actually behave like humans, we might want to take those lessons that we've learned about the brain into how we engineer the systems. It's very hard to convince engineers to take this seriously because, you know, they're just trying to make something that works. They don't really care if it works like the brain or not.
Yeah.
But I think that would be a very promising direction.
Yeah. Well, it's such an exciting time. It feels like a lot of these areas of science are converging. You know, you have these new computational models that you can look at. You have the neuroscience. You know, you have large data sets that we can look at, experimental data. It's really cool that these all seem to be kind of converging, and there's like really interesting stuff happening, and
Yes.
that maybe we'll be able to answer in a lifetime. Whereas like for decades and decades and even millennia, like so many of these questions were open.
And one thing that all of my colleagues say, and I say too, is like we never thought we would have these tools like in our lifetime, right? If you had asked me in 2010, I would have, I would never predict we would have ChatGPT. And the progress is so fast that the type of research we could have done 3 years ago is not the type of research we can do today. Like every year we can do so many new things, and I do think these research areas are converging. So one of the things that I'm really excited about and we try to do in my lab is take methods from cognitive psychology and from neuroscience and apply them to large language models. To do the things we did with humans on these models, to ask whether they solve the problems of language like humans do. And of course, you can do many more things with these models that you can't do with. Right?
Like unethical.
Yeah, you can control how they're trained, right? You can train them from scratch and know exactly what goes in. And so I think this is very, very exciting.
That's so cool. Yeah. And it seems like, at least, even though that there's so much more to be discovered, that these models have kind of shown certain ways of thinking to be wrong. For example, like the fact that we would need an innate language module to, figure out verb movement and those kinds of things. It seems like we can sort of move past some of those types of ways of thinking and move to different sort of theoretical models for this stuff.
Yeah. I still think people really vary there. It depends on what camp you come from. I come from the camp that is more usage-based language, right? That says you don't need a lot of innate, you need something innate, right? The ability to learn. But maybe with even very general and broad biases, nothing that is language specific, you can learn a lot just from usage. And large language models are sort of an example of how powerful that is, at least in principle. Yeah. Some people say these large language models are so different from humans that they tell us nothing. I don't like that view. I think sort of ignoring the first system we have that uses language on par or in ways that are very hard to distinguish from humans, I would say it like that. Maybe not impossible to distinguish, but hard to distinguish. We have that system. We should be very curious about that. So some people still say they don't study like humans. They don't tell us anything about humans. I agree with what you said. I agree that these networks told us that, contrary to the claim that you need some very narrow hypothesis space that you're born with about what language is like. For example, you have to know that language has hierarchical structure and not just linear structure. And you have to have this very small hypothesis space to choose from because that makes the learning easier. Large language models showed us, no, you can have a very broad hypothesis space, right? Large language models are basically machines that link input to output, and they can represent many, many, many different mappings from input to output. They are very unconstrained. So you can take this and you can think of each type of mapping as a hypothesis, right? Of how do we use language? They can have this massive hypothesis space. They can learn so many different mappings. And they have very weak, what some people call soft biases of learning. And that seems to be enough. Again, there's this issue with the data gap that they might require a lot of data. I think it's a matter of evolution versus development, but I might be wrong. It's kind of a feeling, not based on empirical data.
Yeah.
But I think it really supports the usage-based perspective of how much you can learn just from use.
Totally. It makes so much sense to me seeing how kids develop language. And, it feels pretty obvious like that we don't start from rules, and it makes sense because, all these old models, they used to try and start with like these rules of sentence processing. And then like, you put an ED at the past tense or something like that, and then see how good they got at language. And those ones did not do well.
No.
Not at all. And so, it makes sense to me that we don't start with these rules and then, create language. We really, from usage, from experience, we sort of gain intuitions about these patterns that exist already in language.
Yeah. And even once we learn them from the input, there were a lot of questions of what is the nature of what we learn, right? So even if you and I agree that, yes, a lot more is learnable than what some people have claimed, what is it that is learnable, right? Like how is it stored in our mind? How is it represented? And there's still, there was this thought that these are rules. These are hard rules that you can maybe write like rules in a computer program. You go to an interlinguistics course, something like, a VP can be like a verb phrase can be broken into a noun phrase and whatever, or a verb and a noun phrase. When you open large language models, you mostly don't see these hard symbolic rules. You see something that is more noisy, more fuzzy. That's why I try to say regularities rather than rules. And it suggests at least that it's possible to behave in a way that looks rule-like. One of my colleagues once told me, it looks rule-like if you squint. If you ignore how messy everything is. If you sit in your lab as a linguist and only take the beautiful examples, then it looks like a rule. But in reality, you might only learn soft, fuzzy irregularities, and it might allow you to behave in a way that traditionally we had thought was evidence for rule.
That almost feels like the way everything works in the world, like that, nothing is at this, very specific level. We can't make any, exact predictions, but as data scales, we get more and more examples of something. It becomes more, you see a bigger pattern that emerges.
Right. And the rules are super useful because they are sort of a story that we as scientists can tell ourselves to understand what's happening. And I don't mean a story in any bad way. It's very helpful. But it's also important to think of what level of explanation is this story told at, right? It might not be told at the level of this is how it's actually implemented in the brain, but rather this is an abstraction that helps us, as you said, make sense of all of the data that we get as scientists. Right. Cool. So thinking of a rule is sort of an analogy or a metaphor rather than a hard claim about how things actually are.
Yeah. And just to make this practical for SLPs too, I see so many goals that are like, teach this child, the ing or the past tense or like these things. It's like, that's not the way you don't teach these rules explicitly. You pick these up from lots of input and rich interactions.
Yes.
And they need to cross contexts and all that. Yeah. So
yeah. And even think about, I think about it because I don't have experience with SLP. I learned English at a later stage in life. I started at age 7 or 8, but it was, 1 hour a week in school. Like it wasn't a lot. And there they teach you the rules, right? The how to convert something to past tense and how to build sentences in, past progressive or past perfect or whatever. And my English was fine-ish, especially with reading, but talking, my grammar was very bad, even though I could list all the rules way better than all my friends who spoke English from childhood. It wasn't until I had to move to the US and use it, as you said, that I got much, much better. The rules didn't really help that much.
Yeah, exactly. So maybe we could switch over to just a little bit of brain stuff. I think this is so cool. And also, maybe this stuff is a bit more familiar to SLPs, but the one area that is taught in like every class that I've started with in grad school is like Broca's area, Wernicke's area. But maybe this is a bit misunderstood. So I was wondering if you could talk about Broca's area and how I think you used the language of natural kind, but how this is not a natural kind.
Yeah. So this is, I have to say, a lot of this research, this was done in my graduate school, and a lot of this was, or predated me. So Ev Fedorenko, who you hosted, my advisor, initiated a lot of this, and I was very, very lucky to join her in this, for her to sort of invite me on this journey. But I think there are two main things that are interesting about Broca's area and that are surprising if, compared to what you would read in most textbooks or learn in most intro classes. One is that it's not super strongly associated with Broca's aphasia in the sense of one-to-one. So there are some cases where people get a lesion somewhere else and they would be classified by some as having Broca's aphasia. And there are some cases with people with lesions in Broca's area that would be classified by some as not having Broca's aphasia, but having a different problem. And it's confusing because we use the same name for the disorder and the region, right? We use Broca. Not to mention that, some physiologists would say that even the name Broca's aphasia is sort of not very good because there is such diversity, and we sort of use it because we haven't come up with anything better. But there's so much variation inside that, that disorder in itself is not like a kind. So that's one thing. The mapping between the disorder and the brain region is not neat and perfect. The other thing is that Broca's area itself is not one area. It's not a monolith that just does language. It, in fact, consists of many sub areas that do very, very different things. So there is one sub area that seems to be important for articulation. So for the motor commands, right? Not for comprehension, not for writing when you do motor commands with your hand. So just for articulation. There's another part that seems to care about language, both input and output, but not motor commands. So more at the level of meaning and structure. Whether you listen or read or see signs or speak or use signs or write, doesn't matter how it comes in or out. So it's more high level abstract language. And there's another part that is related to what I mentioned, this IQ or intelligence, what sometimes we call executive functions, right? Working memory, inhibition, things like that. And those parts are very different. They do different things. They contribute to language and to cognition in very different ways. And so when scientists say something happens in Broca's area, we used to say this because we didn't know any better. I think these days we should stop saying that because it's very confusing, right? It's sort of, but which part of Broca's area does it happen in, right? So if I say, response inhibition and something like syntactic regularities happen in Broca's area, it might sound like I mean the same neural circuits are doing both, but that might not be true. It might be different sub areas that are doing each of these.
Yeah. Wow.
And so, so Broca's area is it should be divided into subparts. And to the extent that we can, we should stop referring to it just as Broca area. So I try to say the language subpart of Broca, which is hard because it's longer and who wants to speak that way, but, trying to be more specific.
Yeah. Oh, that's great. And actually this is great because it's more specificity than even what Ev was talking about. Because when she came on, she mentioned that just the original, like the very first time that it was characterized or classified, when Paul Broca looked at this area, that was actually the part of the left frontal lobe that was really about the motor stuff and not the language stuff. And so something that I had wrong for a long time is that a lot of times you can have intact internal language structures, even expressive language structures, but because of the motor issues, you can have you can not be able to express that. And a lot of the times when we say Broca's aphasia, it's like expressive language, but that's not really the right term.
Right.
Yeah.
Right. I fully agree. And it's really interesting, there are all these studies where even with people who seem to have problems with syntax when they need to express it, they can behave in ways that suggest that the knowledge is not fully gone. So if you think of what these patients are trying to do, which is communicate, right? We don't communicate structures, we communicate meaning. And if you have some motor problems that make it hard for you and very effortful to speak, you might want to speak minimally to save effort, and you're only going to say the things that matter the most, which is not function words like of and the, right? They're content words because that's what gets the meaning across. And there's work, since the 80s, but extending until today that shows that what these patients are doing seems actually very, very rational, given the types of errors that you make. And yeah, sometimes an error might look like an impairment might look like it's a language impairment, and it's not. It's a motor impairment.
Yeah, it seems like a very rational compensatory strategy if your language structures were intact. Yeah. Do you have anything to say about Wernicke's aphasia? I mean, it's something so mysterious, but yeah.
So I'm not an expert on Wernicke's aphasia at all. The one thing to say is that just like Broca's aphasia, right, there's a lot of variation under that umbrella term. So that umbrella term is useful only to the extent that we haven't come up with anything better. That one also does not map into Wernicke's area neatly. So you can have damage around Wernicke's area and you would not be classified necessarily with Wernicke's aphasia. And vice versa, you could get damage somewhere else and maybe you would be classified as having Wernicke's aphasia. So it's also, there is a correlation, but it's not a one-to-one thing, which complicates this. So with Wernicke's aphasia, it's also interesting because, for example, one of the interpretations there was that there's something wrong with receptive, for example, syntax, right? It's sort of syntax is on, you give them, show, as you said, show me the girl that the grandmother is kissing and they can't choose a picture. I think there's at least one study, I might be wrong, but I think there's at least one study that shows that the people who study with these kinds of tasks, which again, also these tasks have an executive problem-solving component, but let's put that aside. The people who are bad with these kind of tasks, sometimes if you just ask them, is this sentence grammatical? Like, I know you don't understand it, but just tell me if it's grammatical. They do better than Chan, right? So you can't just say syntax is gone, right?
Yeah.
Something is there and it might show itself depending on the type of task you do.
Yeah, it reminds me of when we were talking before about kind of knowing the definition of word, like you have like some intuition about it, but it's not. There's this continuity and it's not just like a either or situation. Like, language or you don't. It's like there's a scale. So getting back to kind of I think what's so fascinating about your research as well is just that like there is this modularity of the language network. Whether it's Broca's, Wernicke's, there is something that is activated for language tasks that doesn't seem to do much else. And I'm wondering if you could talk a little bit about maybe that dissociation between the language network and other areas, like, a lot of the claims that we were talking about before that, hey, you need to activate your problem solving skills to do language. Yeah. What do you have to say about that?
Yeah. So the word modularity is a very loaded term. And I think it's very interesting because originally when people like Jerry Fodor proposed the idea of a modular cognitive system or brain system, they listed many, many characteristics that a modular system would have. And today we know that very few systems, if at all, have all of these characteristics. And it's confusing because when you say that some system is modular, some people think that what you say is that it has all of these characteristics. So for example, one characteristic is that it's domain specific, that a modular system has its own domain of inputs that it cares about, and it does just that thing. And the language system seems to be very, very strongly language selective. It's still an active area of research, but so many types of cognitive processes that philosophers have claimed rely on language don't recruit the language system. Like the language system doesn't care about them at all. So it seems to be very, very language selective, or at least strongly language preferring, like preferring to do language and other things. But another aspect of modularity is penetrability, is that modular systems are impenetrable to external interference. So they do their own thing and nothing else can sort of interfere with them. You can kind of think of this as like the Queen's Guard in England, right? They stand there, they do their own thing. You can come and try to make them laugh. They do their own thing. We don't think the language system is like that. And we don't even need neuroimaging for that. There is so much behavioral evidence that, for example, visual information from the objects around you can affect language processing super early on. That your knowledge of what other people know, the contents of their mind, can really affect how you interpret what they say very early on. So the language system is modular in the sense that it's domain specific, it's not modular in the sense that it's impenetrable. It's very penetrable. And of course, it collaborates with many other brain networks, right? Language is not isolated. Because we use language, right, to express many, many things. And, if you didn't have conceptual knowledge about how the world works, it wouldn't really help that you know how to use language correctly, because you would just say nonsense. So that network is definitely penetrable to other sources of information and communicates with other regions. I also don't want to say that it's the only network that does language. So there's a difference between saying this network only does language and saying only this network does language. And I mean the first, right? That network only does language. I don't mean that it's the only part of the brain that contributes. Other parts can contribute as well, especially depending on how broad your definition of language is. So that's important. One thing that I'm kind of proud of that I did in grad school, almost without intending to, is a lot of the tasks that have been studied to see if they activate language regions are sort of very narrow domains. Like, does the language network care about arithmetic or about music processing or about, about facial expressions? And these are super important because they're having many claims that those things engage language. But some people say, well, okay, but what about like thinking, right? Like thinking is sort of knowing what's happening. Like surely that engages language, right? Like it's sort of, all these artificial tasks and specific domains, whatever, fine. Okay, we were wrong. They don't require language. But what about, this building thoughts? And what I was able to show is that the language system seems to integrate information from the level of syllables and words up to the level of a sentence or two, but not that much beyond. So for example, building sentences into a paragraph or building paragraphs into a narrative, as when you're reading a story, that doesn't happen in the language network. The language network doesn't care if different sentences are coherent together and make a paragraph, or if they're completely independent. And that suggests that it cannot support these long, complex thoughts, right? And these long, complex episodes of experience and narratives. It doesn't have the capacity to integrate information over that long timescales. And I think that's one very, to me, compelling pieces of evidence that we have, that network is not important even for the more abstract type of thinking, as like just understanding what's happening around you.
Yeah, amazing. I feel like we've just gone full circle back to the language is not thought. Yeah, perfect. So cool. We're nearing the end. I just want to open it up to a few, if anyone has any questions, you are, anyone in the audience listening, feel free to chime in the chat. Thank you again so much for joining us. We'll stick around for just a few more minutes, but really appreciate you taking the time.
Thank you for inviting me.
Yeah, maybe if you have any final takeaways, or I'd love to know what you're most excited about now, and what you think are open questions that need to be studied.
I think there are two things that I'm excited about now. One is in the realm of the brain. What is meaning? So there seems to be type of meaning that are maybe specific to language, right? So for example, meaning you can get from how we use words, versus types of meaning that seem more conceptual, right? That even people with language disorders, even very severe language disorders, are able to, use and think and reason. Some people say that that's not true, that all meaning is conceptual, there's no language-specific meaning. I disagree, but I don't know where the divide is. And I don't think the divide is going to be a strict line. I think it's a continuum, but I'm very interested in what types of meaning are more linguistic, what types of meaning are more conceptual, and how does the brain store and processes them? Sometimes I think that using the word meaning is just a very bad idea because it's so complex and it derails us to thinking that we could ever understand what meaning is, and maybe we should use terms that are easier to operationalize and study, but I'm really excited about what meaning is. And a related thing, I'm really about large language models. I'm very interested in how they combine different information sources. So we know a lot about how they process language. I'm now really interested in things like within language, how do they combine, for example, syntax and semantics, or models that do language and vision. How do they combine those two types of information to support different types of behaviors? So we just started doing things where we look at whether language models use the objects in front of them to interpret the language in a way that for humans, we would call pragmatic sensitivity, sort of reasoning about the content of other minds. I don't want to say that these models do that, but I want to say that it behaves in consistent ways. So thinking about how they integrate different types of information, I think is very exciting.
Wow.
Multimodal processing.
Yeah. Yeah. I've seen a lot of papers come out recently about, using, this is often for trying to model like that open world stuff that you're talking about, but like using an LLM as like part of it, and then some like rule processing, like they're combining different elements together to I don't know, be more flexible about not just playing chess, for example, but how do you solve problems across many different games, and just from like a natural language prompt or something like that.
Yeah. So
cool.
some of these systems, I think those are maybe some of the what you mean, that you sort of take the language model to convert the situation in front of you to something like a computer program, and then you have a separate system that can manipulate that program in more systematic ways to kind of support the behavior. It's very interesting because it kind of makes a claim that like, the language part works in one way, and then the reasoning part works in maybe a fundamentally different way. I don't know that I necessarily agree, but the separation itself, I support.
Have the aspects of, development been studied much? Because that's the field I'm in, more in the how this all develops. And, we know a lot about now that the language system, kind of what it looks like functionally from your research and Abs. But, how that looks when we're developing language. Is it, do we start with using all these networks and then sort of converge on more singular one? They're much.
Yeah. So it's happening, but I think like in the next few years, we'll see a lot of that work. So I know I'm searching for collaborators who know how to scan infants, because scanning infants is a whole very difficult challenge. I know Ev is also doing that. I know some other groups are doing this fascinating work, maybe on kids who are a little older, like 3, 4, 5 years old. It seems like, but by that point, a lot of the architecture of the brain looks quite similar to what it looks like in adults, not fully. So, the language network might not be as selective, or some other networks might not be quite as selective, but it's sort of getting there. You can see that emerging relatively early. I don't know, maybe you think 3 years is not relatively early at all. But I really want to go to like, before you're 1 year old, what is there? Are these systems more integrated and then they separate? Are they separate, but each of them is doing more stuff? And then they learn to specialize. I think we're just starting to get those answers. And I think large language models also hold a promise here. Not so much in terms of the division of networks, but in terms of when and why do you get different disorders of language development, right? Because you can both manipulate the corpus, right? So the type of language exposure you give, and you can manipulate different internal components of the network. Which types of components, when you what we call ablate them or impair them or knock them out, cause which types of developmental disorders. I think that's going to be huge. I think there is promise there to try to figure out what's happening. And once you understand why it's happening, that's the first step to figuring out how to fix it, right? Or at least help those people best deal with whatever condition they have.
Yeah, that's fascinating. We'll be, or I will definitely be following the research with great interest, and I know it will have, huge implications for us as therapists working with different types of, differences in disorders and development. And so important. Thank you so much, Dr. Blank, for doing amazingly important work. If people want to get involved, where can they find you? Are you
so we have
some questions?
We have. I'm always happy to answer questions. People can always email me. The email is on the UCLA website, but it's iblank, I for Idan, Blank is my last name, so Blank, at psych.ucla.edu, or you can just visit our lab's website. It's the Blank Lang Lab, Lang for language.com. Probably if you just type my name into Google, it would lead you either to my UCLA page or my lab page, and from there you can email me. Yeah, I'm always happy. Oh, it's Gary, without the dot.
Oh, oops.
No, it's fine. He put in the chat, it's iblank continuous. Yeah, always happy
Right.
to engage with people who have questions or want to collaborate. Yeah, very happy to share what we're doing.
Awesome. Any last remarks or asks of our small speech therapist community here?
I mean, I'm just so grateful to everyone who's listening, and for you, grateful to you for inviting me. This was really, really fun. I'm always happy to spread the word. Yeah.
Great. Get some thank yous popping in. Thank you so much again. And yeah, anyone in the audience, or thank you all in the audience for coming by and listening. Always great to see some familiar names. And also, I'll be at ASHA. If anyone's coming, please come say hi. I'll be there Friday and Saturday, probably. That's the big speech therapy convention. So, which is why, unfortunately, I missed your talk at UCLA. Yeah, but
That
thank
was
you
like a
again.
many important reasons.
Yeah. All right, everyone. Take care. Stay curious. Hope to see you in the next episode.
Thank you, everyone.
Thank you. All right. Bye-bye.
Bye.